Hello all. So sorry for being a little bit late. Today we're starting our lesson on extensions, and so extension functions, and then extension properties, and then we'll see scope of extensions. I'm not really sure what we have inside that. And so I'm sorry if I didn't stream last time. I couldn't manage to do it. So I have also news. I have set up some live streams also for the next weeks, and I hope you are going to enjoy them as well. And we'll go through all the documentation regarding data classes, generics, and so on, functions in general. And then we'll see these topics in the last lessons. So Kotlin provides the ability to extend a class or an interface with new functionality without having to inherit from the class or use design patterns such as decorators. So this is done via a special declaration called extension function. For example, you can write a new function for a class or an interface from a third-party library that you can't modify. And such functions can be called in the usual way. So this is useful because you can extend some functions of a class or an interface of a third-party library, and you may find this very useful in your code. Such functions can be called in the usual way as if they were methods of the original class. So this is also very useful because you may extend a class by adding a function in there that you may use from you may create on your own code and not ask the developer to implement this function, and then so on and so on. There are also extension properties that let you define new properties for existing classes. So these extension properties allow you to define new properties for an existing class, and we will see it here. So extension functions, to declare an extension function, prefix its name with a receiver type. So receiver type refers to the type being extended, for example, a mutable list of integer, as we see here. And this function, what it will do, it will swap the value from index 1 to index number 2 and temporarily store it inside a variable called temp. So we may start our code today with this simple function. I'm sorry, it's still I think it's still downloading something from the latest fleet update. So I will go on our first lesson. I will go, over here and comment these two lines. Okay, I will mess up with the comments. Okay, so this time play with extension functions, and now we will create this function probably somewhere in our yeah, we have some extensions here, so we may create it here. All right, product extensions, and we can then extend some functions of our product data class. Maybe that could be something interesting. So our product, what it contains is a unit, weight. Okay, it has some things like weight, description, ingredients, and so on. So yeah, let's do something like swap ingredients. So we could go to our extensions, and okay, I don't really like this function here. Maybe we can place it directly inside our main app file, and then over here we may extend our our product. So we'll do something a little different. We create an extension function on product implementation. So swap ingredients, okay? And this will be our function. And so each time we have an instance of a product, over of a product implementation, can actually be a product, so it can be an instance of an interface. What we can do is we can say swap ingredients, so something like, let's take our ingredients. Okay, here it's private. So that's the thing you should be careful on. In this case, the ingredients is private, so we can access it anyway. All right. Because it's not defined on interface. So what we should do is we should have this defined in interface. So we should have our value list of strings in the interface, and this should override it. All right, perfect. Now we can access it, as you see here. And this time, what we want to do is we want to swap ingredients. So we need to have index1 integer, index2 integer, and then we have our list. We save it to to a temporary list as they were doing before, and then we can say temp dot. Let's see how they did it here. Yeah, of course, we should always check if the list will contain that index. So if size, what I would do is this: if index 1 is less than 10 dot size, and index 2 is less than 10 size, we're good. Else we throw an exception, legal argument exception. And now what we can do is we can say, okay, sorry, the temp needs to go here. So we need to pick the first index element. And now we need to do this dot ingredients dot index1 equals to this dot ingredients dot index2. Yeah, wow. Not temp. This dot ingredients. Yeah, I'm a little bit tired today, so let's hope not to make some mess. Of course, ingredients is a list of strings of, yeah, this was integers. So that's the issue here. We're changing the element at inside a list, and this is also not mutable, so it has to become mutable. And then we need to change. Yeah. Okay. Okay. We need to create a template, and this will become our mutable. So we take the ingredients list and we transform it into a mutable list. Then we store, only the value of a certain ingredient at index 1, and then what we do is we change the value of the ingredient at index 1 with the ingredient at index 2, and we do the same with the other one, but we assign temp value. All right, and then now we're good. We have our list with swapped ingredients by giving their indexes. And now we can, of course, return the new list or assign to our ingredients our temp list. But yeah, of course, this is not a value, but a variable. Let me check something. Yeah, it has to become a variable. And this is not good. Because we in this case we should change ingredients. So let me see if we had add ingredient. Okay, we will add a new function just for the ease of development that says replace all ingredients. And what this will do is it will take our list of strings and it will say, okay, take ingredients and assign our replace all. What it does, see, replace. Oh. Is there a way to change the mutable list? Well, if I assign it like this, it needs to be a variable. Wow. So what I would do is remove all and then it needs proof. Okay. And then we do ingredients for each. And then we say ingredients. Oh my god. Add. Yeah, like we could have done like this, probably. So we remove all the elements. Yeah, we need this. Okay, so it will remove all elements and then add new ingredients. And this function will be used. So we keep this as a value so that we're good here. And now what we do is replace let's not replace. Come on. Yeah, because we have to place this function inside our product. And here we have to override. And now we can call it end list. Okay, perfect. Sorry for the confusion. So what I will recap what we have done. So we checked the size that the index 1 and 2 are inside the list size. Then we create a mutable list from our ingredients list, which is publicly available from the interface. Then we take a value in index 1 and we store it temporarily. Then we assign the value number 2 to the index position 1, and then we assign to index 2 the value of the index 1 which was stored in our temp value, and then we'll replace all the ingredients with our newly defined function, replace all the ingredients, which will remove all elements from the list by using the private mutable list, and then we will add all elements from our newly defined list. So let's test this code. We will create a product implementation, and we'll say product implementation, and then let's see what we need to pass. So name and product ID. Let's see what it does, because I forgot this. So yeah, okay. We can say apple, and then we can say, yeah, maybe not apple, but something like banana, and then we say product ID is 1, and then we add some ingredients like pasta and sugo, and so yeah, sugo is sauce, and then we can add how to say bacon, yeah. And now we will swap number 1 with number 0 with number 2. So we say product implementation swap ingredients, which is our extension function, and then we swap number 0 with number 2, and this should work out. So we print all our products. All right, we print them before and after the swap, and we can say it here, before swap, and we can say also after swap. And now we can run it. So we have our extension function, we have added 3 ingredients to our list. Then before the swap, we'll have pasta sauce bacon and then bacon sauce pasta, because we swap index 0 and 2. Perfect. So now let's get back to our docs. So the this keyword inside an extension function corresponds to the receiver object, the one that is passed before the dot. Now you can call such function on a mutable list. So we have seen this right now, and this function makes sense for a mutable list, and you can make it generic. Okay. So yeah, this is for generic lists. So in our case, we have defined something that works only for product interface. So if we had a different product implementation, that would work out also for that. But generally, this could also work in general for any list, if we just need to recode it a little bit, like they have done here. Okay, So yeah, maybe we can show it very quickly. Let's try and do it. So we add our generic implementation. This is a generic implementation. And now here we have our mutable list, right? So what we could do is, okay, maybe we can say temp list dot swap, and then we're passing the index 1 and index 2, and this will work the same as before because we're using our mutable list generic implementation. So let's run it. Yeah, as you see here, it works. So you may reuse this extension function in other parts of your code as we're doing for the swap ingredients extensions. All right. So as you see we also see that we're extending product, and this product might also come from another package, like not inside our package Kotlin org, but maybe from other libraries. Like also it could be from Kotlin native libraries, so like string and so on. In fact, mutable list is from Kotlin native library. Okay. So next, extensions are resolved statically, so they do not actually modify the classes. They extend. By defining an extension, you are not inserting new members into a class. Okay, so that's important. Only making new function callable with the dot notation on variables of this type. So you're not actually creating new functions, but yeah, new members in the class, but you are making functions that are callable on those classes. Extension functions are dispatched statically, so which extension function is called is already known at compile time based on the receiver type. So for example, if you have a shape, yeah, you create two functions, one extension function of shape and one of rectangle, and you call the print, then you will get, okay, as the shape, yeah, this will call probably the shape. Yeah, it will print the shape, as you see, because the extension function called depends only on the declared type of the parameter, which is the shape. So it doesn't take into account that this is a rectangle, because yeah, since it's now at compile time, probably it will replace it with the shape value directly here. If a class has a member function and an extension function is defined, which has the same receiver type, the same extension name, and is applicable to given arguments, the member always wins. So for example, yeah, we have our example print function type, which prints extension function, okay. The member, this will print out class method. So I wouldn't allow this. I don't know why they allow this extension to exist actually. Yeah. Very strange. Let's try and create like maybe no change weight, yeah. Let's try and do this. Change weight. Okay, it's allowed, but as you see, this is shadowed by a member. It will say this to you. So we just delete it. We don't do this anyway. However, it's perfectly okay for extension functions to overload member functions that have the same name but a different signature. Okay, so that's totally fine. You can use a different signature. But yeah, like change weight. Yeah, here it doesn't make a lot of sense. And we have weight value. We could change weight unit, maybe. Weight unit, and this is totally fine because it has a different purpose, and yeah, maybe also signature. Yeah, if you do it like this, it will shadow anyway. Yeah, the unit should be unit, so this will work fine. Nullable receiver. Note that extensions can be defined with a nullable receiver type. These extensions can be called on an object receiver even if its value is null. So if the receiver is null, then this is also null. So when defining an extension with a nullable receiver, we recommend performing a this equal null check inside the body function to avoid compile error. Okay. You can call toString in Kotlin without checking for null, as the check already happens in the function. So yeah, we can check that. But basically, what they're saying is, if you want, you can do something like, if there's a product, swap ingredients, index 1, int, and index 2, int, then what you can do here is, if this equals null, then print no ingredients box, and else we can swap ingredients, index 1, index 2. Yeah, and that's it. You can print them. I print swap ingredients because product is null, and that should work fine. So let's try and call these. Yeah, maybe we could do something like swap ingredients. That would be nicer. Perfect. So swap the ingredients. Let's call these. Maybe we call them here. We can remove the parentheses. No, we don't need actually the print line. That's okay. Let's run this. So yeah, why don't we have print swap ingredients? Okay, run. So yeah, okay, swapped ingredients is a Kotlin unit. Why? Yeah, because we're printing this. Okay, we should do this. Now it makes more sense. And of course, now it gives the same result as our last line here. And what if we start this on a null product? Then probably we know what will happen. So we set this to null. Let's call this product implementation nullable. Now we add all the question marks in order to run this safely, this function safely. And then we give it a value of null. And then we call the swap again. And let's see what happens. Okay, so we have our no ingredient swap because product is null. So it's behaving as they have suggested in the docs. Extension properties. Yeah, extension properties are supported, and basically we can you create a getter for some function. Like in this case, we can take the last index by taking the size of the list and calling -1. So as you see, initializer are not allowed for extension properties because there's no efficient way for an extension property to have a backing field. Their behavior can be defined by explicitly providing getters and setters. So as an example, house.number equals to 1, initializers are not allowed for extension properties. So it gives an error. So let's try this. Maybe we can create a fun product dot yeah. What happens if we create an extension of product which is not nullable? We'll see it in our app code, but here I want to create a property, right? So like size, ingredients size, and this function, what it will do is it will get the list of ingredients. Yeah, have to define that it's integer probably. And read inside must have a body, okay? Get ingredient type. What's from okay, why did I do function? So this is value. Okay. So we have a value which is now our extension property, extended property, and this will take each time each time ingredient size is computed, it will take the ingredients size and output that to us. So let's go here and let's call this on our code. Project implementation, ingredients size. Perfect. So as you see here, we need to either null assert this or place question mark. This time I want to null assert because I'm sure that we have an implementation for that. Okay, so we have our size over here, but what we can do is also go over here and place it here. So now this extension function will call our extension property, which is pretty nice if you ask me. That may make your code a lot cleaner if you want to extend some properties of classes that you don't own. Companion object extensions. So if a class has a companion object defined, you can also define extension functions and properties for the companion object, just like regular members of the companion object. They can be used using only the class name as the qualifier. So yeah, you need to call dot companion, but you should have our the companion object. I don't think this will work on the interface, but we will try. So function product dot yeah, we could move the print companion and yeah, it actually works also on the no yeah, as you see a result reference. Maybe what happens if we have a companion object here? It's allowed. Yeah, it's allowed also on the interface. And that's good. So we have our companion object here. Now we can say print line all our ingredients are ingredients. Yeah, now this time you see we don't have access to properties because this is a companion object. We will need to this is a static function, so we don't have access to product values or functions. So this case could be useful, but for example, to create a companion, maybe to create a product. Sorry, maybe let me think. So create product test, and we can do test equals to product implementation, and then we have test, and then we have the product ID 2, and then we call test.ingredients create product test, and then we return test. So we change our type here, and now we go here, we say bring line, and then we do create product test. So product dot create product test port class. Okay, and this should okay, that means actually to call the print. This will call the print on its own and return the test product. Okay, so as you see here, we have no ingredients, but maybe we can add them. I test out add ingredient tests. Yeah. run, and we're good now. So this is an example of a companion object. Yeah, I've used them a little in some in some of my code just as a mean of creating an instance of the class, like we're doing here, and to return that class. So that's why I might have used companion objects in the past, and these they look very similar to static functions from Java. So let's have a scope of extensions. In most cases, you define extensions on the top level directly under packages. So yeah, like we have done actually. To use an extension outside its declaring packages, import it at the call site. Okay, that's all. Very useful information. Declaring extensions as members. You can declare extensions for one class inside another class. So yeah, inside such an extension, there are multiple implicit receivers, objects whose member can be accessed without a qualifier. An instance of a class in which the extension is declared is called a dispatch event receiver, and an instance of the receiver type of the extension method is called extension receiver. So an instance of a class in which the extension is declared, an instance of a class, so an instance of connection, for example, in which the extension is declared, or in which the extension function is declared, is a dispatcher receiver. And an instance of the receiver type of the extension method, so an instance of the receiver type of the extension method is the extension receiver. And an instance of the receiver type of the extension method is called an extension receiver. Okay, so probably the extension receiver. I'm not quite understanding this. Okay, and an instance of the receiver type of the extension is called an extension receiver. So yeah, who receives the extension is the connection, I think. And the instance of the class in which the extension is declared is the dispatch receiver. All right, so probably .connect. I don't know what the extension function. I don't know what this means. Well, yeah, well. Anyway, in practice, what they've done here is that they have created a function extending also the host class and creating a new method for host class, which is print connection string, and this will print host name and it will print port. And the port, however, is given by the connection and not by the host. So this extension function will use connection.print port, and this might be useful in some cases. In the event of a name conflict between the members of a dispatch receiver and an extension receiver, the extension receiver takes precedence. So refer to a member of the dispatch receiver, you can use the qualified this syntax. So yeah, it will, yeah, if you want to use the toString method of the connection, then you have to use the qualified this syntax in order to call connection.string instead of host.string. So the dispatch receiver is probably this at connection, and the extension receiver is toString, is host. Probably that's how it is. Extensions declared as members can be declared as open and overridden in subclasses. So yeah, you can have an open class, and you can override. Yeah, actually, they're saying that you can override extension functions of other classes that are declared inside a certain class. So like you can override base.print function info if you are implementing base caller. That's what you can see here. And this will will actually perform the override base extension function in base caller. So yeah, this is because it's base caller implementation. So yeah, this is an instance of base caller, and inside, yeah, and if we call derived caller, the override will take precedence over, yeah, it will be called instead of the overridden method, of course. So extension functions utilize the same visibility as regular functions declared in the same scope. For example, an extension declared at the top level of a file has access to other private top level declarations in the same file. If an extension is outside its receiver type, it cannot access the receiver's private or protected members. So yeah, like we have seen before, we cannot access private members like these ingredients because it's private. And yeah, as you see, I cannot go. Yeah, actually here it's because this is the interface, but if we had, cannot have a private, probably here because it's an interface. So here it doesn't make sense, but if we had an instance of product implementation, like product implementation text, we cannot call this dot ingredients. We need to make it public in order to access this ingredients value. Right? And let's remove this. Perfect. So we're done with the extensions. Let's see how much time we've got. Yeah, we are an hour in the class. Let's see how much we have here. Yeah, this should be very quick. So we have already spoken about data classes. Let me see. This was actually a data class. Yeah. So the product implementation was already a data class. Data classes are used to hold data. For each data class, the compiler automatically generates additional member functions that allow you to print an instance to readable output. So this is something we have seen already in the past, and we have seen it also today. Nope. No, we're not seeing it today, sorry, but we can. So if I do print dot product implementation, and maybe I do it before setting it to null, we will see, yeah, here we had overridden the declaration of the toString, but toString /n. But in theory, the data class will have a toString method already, and it will also have the ability to compare instances and the ability to copy instances. So for example, what we can do here is we can create a copy of it, and we can have product ID under 4, for example, and I can print it. So as you see over here, yeah, we don't print actually the ID. toString. So let's print the ID as well. Let's run it. Okay. Yeah, we're missing a comma. So now we also print the product ID. Nice. So as you see, we have a copy of our first instance, and of course, if we compare them, they will be different. So if I go here and I say print, so yeah, if I do this like product in equals product in copy, then they will be equal. Otherwise, I do product ID number 5 or 4 or whatever, it will be different. So as you see here, we have true and then we have false. So the equal will compare all the values, the properties of our data class, like name and product ID, and it will check if they're equal. If they're not, then the value is false. If they're equal, the value is true. And this is different for normal classes, because as we have seen, in normal classes, equality needs to be overridden in order to perform as data classes do. So we create equals, hash code, toString, user. Yeah, the toString in the form of this. So properties and values, and class name here. Component and functions corresponding to the properties in their order of declaration, and then the copy. To ensure consistency, the primary constructor must have at least one parameter, so we cannot declare data class without parameters. As you see, it must have one. Otherwise, you will need to create something which is not a data class, but it's an object, for example. And the primary yeah, all primary constructor parameters must be value or variable. Data classes can't be abstract, open. Oh, shoot. Data classes must. Oh, where are we? Here. They can't be abstract, open, sealed, or inner. Additionally, the generation of data class members follows these rules with regards to the members' inheritance. So if there are explicit implementations of equals, hashcode to string in the root, in the data class body, or final implementations in a superclass, then these functions are not generated and existing implementations are used. Okay. If a supertype has component and functions that are open and return compatible types, the corresponding functions are generated for the data class and override those of the supertype. If the functions of the supertype cannot be overridden due to incompatible signature or due to their being final, an error is reported, okay? Providing explicit implementation for the component and copy function is not allowed, okay? Data classes may extend other classes. So yeah, they can extend other classes. And yeah, here they say extend seal classes and interfaces, but we'll look at this in the next lesson, and it will be quite interesting, I think. Yeah, you can define also default parameters, default values for the properties. And you can have, so yeah, if you want to exclude a property from the initializer, you can do that. And in this case, the variable age will will be initialized with value 0. And in order to override value 0, you need to access it from the instance of the data class. So what this means is that, as you see here, we have to create an instance first, and then we have to set the age in this way. Then it will be allowed. All right. And here you can see that you have equality between person 1 and 2, and this will be false. It's true. Okay, it's true because it only compares the members defined in the primary constructor for which functions are automatically generated and will not take into consideration the variable age, which is something to be careful on. Okay, so actually they will be the same object, and you might think that they are actually not. So let's read this very quickly. The compiler only uses the properties defined inside the primary constructor for the automatically generated functions. So that's what we just said. To exclude the member property from the generated implementations, declare it inside the class body. So in this example, only the name property is used by default inside the toString equals hashcode and copy. So in all of these functions, and there is only one component function, component 1, the age property is declared inside the class body and is excluded. Therefore, two-person objects with the same name but different age are equal. So copying. Yeah, copying is something where we have already discussed. But this is basically what it does. It takes all the properties, and it will use the this as default, this dot name, this dot age as default. Otherwise, you can pass a new value for age and or a new value for name. Data classes and destructing declarations. Yeah, of course, here they have a different constructor from what they had here. Component functions. So what are those? They are generated for data classes, and they make it possible to use them in destructing declarations. So that's interesting. I didn't know this. So you can have a destructive declaration. For example, you can treat properties of name and age and create two values from those. Let's see. Yeah, we can do it with name and product ID, for example. So let's do combine strategy. Destructing declaration, and this will be val. So name product ID. So we have to parentheses name product ID, and this is our destructive declaration, and then we have test product implementation, and then we can say name and product ID, and we run it. We have test and two. Pretty nice. So let me check something. Component. What is this function? Yeah, it's actually referring to the name and product ID. Okay, so component 1 and component 2 classes are actually the name and the product ID. You see? And that's something that probably is useful for destructing declarations. Nice. So the standard library provides the pair and triple classes. In most cases, though named data classes are better design choice because they make the code easier to read by providing meaningful names for the properties. So even though you have pair and triple, it's better to use a data class instead of a pair and a triple. Okay, so I think instead of having this, it's better to have a new data class, like we have done with the product. Okay, so let's all get to our code and replace the pair with a new data class because it's better. So for today, I think we are done. I am done because I'm quite tired. I hope you enjoyed the video anyway, and that you will come back and subscribe to the channel so that we can have more interesting videos in the future. And thank you very much for watching. Bye.